Hello once again. Good morning, good afternoon, or good evening, whenever it is that you are watching this video. So this is the fourth video in our chapter 9 series. And in this one, we will continue with 9.3b, where we will analyze the process in urine formation. So how does the kidney produce your pee? So it involves three processes, not step, dia proses. Dia berlaku lebih kurang serentak bergantung kepada tempat mana darah tu sampai. Okay, so it's going to involve three processes, which is ultrafiltration, reabsorption, and secretion. So if you are ready, let us begin. Okay, so yeah, it involves three basic processes. This is a diagram that you can use as a reference. Okay, so this is what your nephron looks like in case you forgot what a nephron looks like. So there will be glomerular ultrafiltration, ataupun kalau kamu tidak tulis glomerular, tulis ultrafiltration saja pun tidak apa, itu akan berlaku di glomerulus. There will be reabsorption in the proximal convoluted tubule, at the loop of Henle, and at the distal convoluted tubule. There will be secretion at the proximal and the distal convoluted tubule. And the collecting duct pun akan ada absorption and secretion. Okay, so let us look at the first process that is involved, ultrafiltration. So this will occur in the Bowman's capsule. It is the forced removal of substances from the blood in the glomerulus into the Bowman's capsule. Example of things that are forced out from the blood are water, urea, vitamin, bicarbonate ions, hydrogen ions, and other solutes such as glucose, amino acids, and sodium chloride. Things that are retained in the blood are things such as blood cells, platelets, and other large plasma proteins. So basically, small stuff will get filtered out of blood, big stuff stays in the blood. Okay, so this will occur over here. The filtrate, as you can see from this diagram, is water, blah, 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 blah. Okay, so how does the Bowman's capsule and the glomerulus make it possible? Okay, how is it possible that these things are squeezed out of the blood and into the Bowman's capsule? Well, there are several factors. The first factor that makes ultrafiltration good and successful is the high hydrostatic blood pressure in the glomerulus. So due to the diameter of the efferent atriole being smaller than the afferent atriole, the blood in glomerulus will have higher blood pressure than in the other capillaries. Sebab kamu bayangkan kamu daripada lorong yang luas, tiba-tiba kamu kena paksa untuk masuk lorong yang kecil. Masa kamu mau dari lorong luas masuk ke dalam lorong kecil tu, mesti kamu bertolak-tolak, kamu jerit-jerit, kamu stres kan. So just like that with the blood cells, when they are going from the afferent atriole into the efferent atriole through the glomerulus, they are going from a wide hallway into a narrow hallway. So there's gonna be increased blood pressure. Dia makin tolak-tolak-tolak sampai molekul yang kecil akan tertolak keluar daripada glomerulus. So the smaller substances in the blood are going to be forced into the Bowman's capsule because of this high hydrostatic blood pressure. Another factor that makes ultrafiltration possible is the highly coiled glomerulus capillaries. Because it's highly coiled, there is increased surface area for ultrafiltration because the glomerulus is now long and extensive. And the third factor is the high permeability of the glomerulus because of single cell thickness and fenestration in endothelium. Glomerulus tu, the blood capillary that is called the glomerulus is only one cell thick. And the endothelium, which is the Bowman capsule yang sebelah glomerulus tu, dia ada fenestration. Fenestration means lubang. The endothelium that is next to the very thin blood capillary has holes. So this means that it is permeable to water and solutes. Air dan benda-benda yang terlarut dalam air senang untuk limpas. It is also impermeable to blood cells and plasma protein. Sebab masih ada membrane yang jaga kan? So, blood cell dengan plasma protein tidak dapat melalui. Okay, so let's look at the filtration membrane components in the glomerulus. Sekarang kita cakap itu glomerulus, the blood vessel that is doing this stuff. There is a filtration membrane component. The fenestrated endothelium of glomerulus allow solute and fluid but not blood cells, platelets, and plasma protein. The basement membrane or the basal lamina allow passage of molecules depending on molecular size, shape, and charge. This prevents plasma protein being filtered out from blood capillary. There's also filtration slits, which is spaces between the foot-like processes, which is the pedicels or podocytes, makes it impermeable to blood cells and plasma protein, and the slit diaphragm prevent medium-sized proteins from passing through. Okay, here's some diagram. Kaya kalau kamu tengok dalam itu glomerulus, dia akan nampak macam ni. If you look at it under a microscope, you're going to see this disgusting looking thing. So this is that blood capillary which is surrounded by endothelium. Okay, this podocyte is a cell. Satu podocyte ni adalah satu sel khas. Podocyte ini dia ada macam kaki-kaki kecil. Itulah nama dia podocyte kan, podo. And then dia ada pedicel iaitu kaki-kaki jari jemari kecil. So dia akan macam membungkus setiap capillary itu. Untuk di antara pedicel tu akan ada ruangan untuk benda-benda yang kita mau filter. So water, solutes, all that stuff is going to go through these little holes. But bigger stuff cannot pass through those holes, those filtration slits. So this is what it looks like if you cut it and you look at it from another angle. The epithelial podocytes, yang sel yang berjari-jari jemari tadi tu, dia akan nampak macam ni. Jadi di antara jari jemari dia akan nampak begini. Akan ada satu basement membrane. Lepas tu ada endothelium. Di bawah dia adalah capillary. Okay, so this is your epithelial podocytes, basement membrane, endothelium, and capillary lumen. Filtration slit di sini. Slit diaphragm is like this thin membrane, this thin diaphragm that prevents big stuff from passing through. Fenestrae, however you want to pronounce it, is the ruang kosong antara endothelium cells. So you see from the structure here, this is how it allows smaller things to pass through, bigger things to stay inside the capillary. Okay, this is another diagram showing more or less the same thing, just with a different angle and more labels. Okay, same thing as I said before, cuma ini lukisan orang lain lah. Dia tunjuk podocyte dengan cara lain. Dia ada label-label lagi. So these three diagrams are more or less the same. Okay, another one. This is the glomerulus, the capillary, and then ini ada epithelium cells. Okay, that is pretty much it for ultrafiltration. We are going on to the second process involved in urine formation, which is reabsorption. So this reabsorption, serap semula benda yang kita masih maut daripada filtrate. It occurs at the proximal convoluted tubule, loop of Henle, distal convoluted tubule, and collecting duct. Reabsorption is the movement of substances in the glomerular filtrate back into the blood capillaries via passive or active transport. And you can see here the substances that are reabsorbed back into the blood are glucose, amino acids, vitamins, most of the water, and ions. Ions such as sodium, chloride, potassium, hydrogen, and bicarbonate. Sebab dia adalah, masa ultrafiltration tadi, memang dia main paksa saja benda keluar. So, ada benda yang badan kita masih perlu, nephron tu akan ambil semula supaya tidak hilang. Like, of course you're gonna need water. Nanti kamu dehydrated, so it's gonna take most of the water back. Dia akan ambil balik gula because, you know, your cells need glucose, your cells need amino acid, your cells need vitamins, and it needs the ions. So, benda yang masih berguna ni, nephron kita akan serap semula. Reabsorption. Reabsorption is the process where substance from the filtrate is reabsorbed into blood capillary. Reabsorption dia terbalik sedikit dengan secretion. Secretion pembuangan. Secretion is the process where substance from blood capillary are secreted into filtrate. Okay, so dia arah yang bertentangan. So the blood capillary can be peritubular capillary or vasa recta. Okay, let's look at the reabsorption at proximal convoluted tubule. Sekarang masa yang sesuai untuk kamu ambil gambar nephron yang kamu lukis untuk 9.3a. Take back the diagram that you drew for 9.3a. Take it out, take a pencil or pen, and you're going to start labeling some things. Okay. Let us label with arrows how reabsorption occurs at proximal convoluted tubule. So here, reabsorption occurs by both active and passive transport. At the proximal convoluted tubule, reabsorption is critical for the recapture of ions, water, and valuable nutrients. The things that are reabsorbed by active transport are sodium ion, glucose, amino acids. So, bila kamu tulis sodium ion, glucose, amino acid, sila gunakan satu warna. Kalau di diagram saya ni, saya gunakan warna merah. So, choose different color for when it's active transport or passive transport. In this diagram, I'm using red color for active transport. And then there are substances that are reabsorbed via passive transport. So things that are absorbed via passive transport are chloride ions, water, potassium ions, bicarbonate ions, which is HCO3 negative, and urea. So benda-benda yang passive transport dalam diagram saya label menggunakan pen biru. The processing of filtrate in the proximal convoluted tubule helps to maintain a relatively constant pH in bodily fluids. So, dia akan jaga pH lah sebab ion-ion ni kita ambil balik, kita tidak hilangkan dengan banyak. Okay? Alright. This is a closer diagram to show what you should be drawing. Kalau yang efferent tu kamu tidak melukis macam ni pun tidak apa, asalkan jelas bagi kamu lah. Alright, we are going to look at the reabsorption in the next part of the nephron, which is at the loop of Henle. Loop of Henle ni masa dia turun dan dia naik, benda yang dia reabsorb berbeza. At the descending loop of the loop of Henle, of the loop of Henle, masa dia menurun, the thing that will be reabsorbed is water only. Reabsorption of water will occur via water channels, or also called aquaporine proteins, make the epithelium permeable to water. Di permukaan epithelium tu, membrane dia akan ada aquaporine protein untuk membolehkan air diserap semula. There are no channels for salt and other small solutes. As a result, the filtrate loses water and therefore its solute concentration increase. Okay, and then it's going to go down, and as it is going up the ascending limb of the loop of Henle, at the ascending limb of the loop of Henle, there are no water channels. Bila dia menaik saja, tube ini tiada water channel, jadi dia impermeable to H2O. Air tidak dapat limpas. The ascending limb of the loop of Henle will have two segments. It has a thin segment and a thick segment. At the thin segment, it has ion channel, and sodium chloride will diffuse out from the tubule into the medulla region by passive transport. Kamu tengok di sini, saya label dengan blue arrow. Bila dia sampai kepada thick segment, sini pun ada ion channel juga. Sodium chloride juga yang kena kasih keluar. But now, sodium chloride is transported actively into the medulla region. Tadi di bawah ni adalah passive transport. Bila dia sampai part yang tebal ini, dia adalah active transport. At the next part of the nephron, the distal convoluted tubule, there will be active transport reabsorption of bicarbonate ion, which is HCO3 negative, and also sodium chloride. Itu potassium dengan hydrogen pun adalah kena serap sikit-sikit. Tapi lebih banyak active transport reabsorption, NaCl, and HCO3 negative. And there will be passive transport of water. Water will also be reabsorbed at distal convoluted tubule, but via passive transport. When it reaches the collecting duct, there is also reabsorption happening at the collecting duct. There will be reabsorption of waters and solutes. Water is H2O. Solutes such as sugar, amino acids, vitamins, and other nutrients. Ini pun akan ikut secara passive transport sebab dia ikut air. Dia terlarut dalam air. At the inner medulla, which is permeable to urea, urea will diffuse out. So bahagian bawah ni, urea akan diffuse out. So dia passive transport. In producing dilute urine, NaCl if actively reabsorbed. Mana NaCl? Okay. NaCl will be active transport reabsorbed out of collecting duct. Supaya kita punya, ya, macam kita masih mau jaga kandungan garam dalam badan dan kita tidak mau kencing kita terlalu pekat. Yeah, that's what it means, dilute urine. Okay. There are adaptations to increase reabsorption in proximal convoluted tubules. Proximal convoluted tubule, which is the bahagian depan-depan tu, dia ada beberapa ciri-ciri yang membolehkan dia sangat efisien untuk reabsorb bahan-bahan ini. So the first is that the proximal convoluted tubule is very coiled, dia berbelit-belit, and it is lined with numerous microvilli. So it has increased surface area for reabsorption. The proximal convoluted tubule also has an abundance of mitochondria, which provide energy for active transport. The proximal convoluted tubule also has pinocytic grooves, which are very small inlets at the base of microvilli. Dia ada macam teluk, macam ada tempat melengkung sedikit. So it enables pinocytosis of smaller protein molecules. Tempat yang melengkung masuk sikit tu, dia akan boleh ngap, ambil, minum sedikit smaller protein molecules. There are also spaces between the tubule cells, so it enables easy passage of substance from inside to outside of the tubules. And they are basal channels. So there are spaces between the cells and the basal membrane. There will be channels that increase the surface to volume ratio for substances to go out from cells to tubules. So here we can look at, this is what the structure looks like in the proximal convoluted tubule. Dia punya sel akan nampak macam ni, dia akan ada microvilli, akan ada tempat untuk pinocytosis di antara itu microvilli. And then you can see the intercellular spaces, you can see at the basement membrane, ada benda, banyak benda dia boleh serap. Okay, the substances entered by active or passive transport into the cytoplasm of the cell and are then moved to the opposite membrane. Anything that is absorbed from this side will be absorbed through to this side. Substances move across the membrane into the basal channels and across the basal membrane into the blood capillaries by active and passive transport. So benda akan naik dari atas, passing atas sini, pas melalui epithelial cell, melalui cytoplasm dia dan kepada blood capillary. Dia boleh melalui active transport, boleh melalui passive transport. Okay, so sekian itu untuk reabsorption. We are looking at the third process in the urine formation, which is secretion, pembuangan. In secretion, it is the removal of waste or toxic substances out from the blood and into the glomerular filtrate. So this will occur at several points. The first point is it will occur at the proximal convoluted tubule. The secretion that happens here is the secretion of hydrogen ion, drugs, and toxins, which is poisons, by active transport. So di sini saya ada tulis drugs, hydrogen ions, and toxins via active transport using red pen. Urea will be secreted via passive transport. So NH3 via passive transport, warna biru. Water can be secreted via osmosis. At the distal convoluted tubule, which is other end, there will be secretion of hydrogen ion and potassium ions by active transport. So distal convoluted tubule, hydrogen ion, potassium ion by active transport. So urea pun akan by active transport here. So it's H plus K plus urea. Pam keluar. So that is pretty much it. This urine in our blood, urine in our pee is produced through three processes. The three processes that are involved in urine formation is ultrafiltration, reabsorption, and secretion. So go ahead and fill in what you feel like you need to fill in your diagram. Kamu boleh ikut diagram saya bulat-bulat. Kalau kamu mau buat cara sendiri pun tidak apa. Ada satu benda yang mungkin berbeza di sini dengan apa yang saya explain tadi. Dalam sini dia ada label bahagian mana adalah renal cortex, bahagian mana adalah outer medulla, bahagian mana adalah inner medulla, mana satu adalah renal pelvis. Another thing you may notice is it includes the pressure. So here it is noting the osmotic concentration. Sini osmotic concentration 1200, osmotic concentration 300 here. Osmotic concentration is highest at 1200 in the inner medulla. Do you need to remember and understand that at your level now? Not really. You can write that down if you want, but that's not important for you to memorize this time. So that's it for urine formation. What should you do now? Now you should go back to your nephron diagram, finish the labeling, and also do question 1, chapter 9 in your PKA booklet. Okay, that is pretty much it from me for this video. Thank you for your time and your attention, and I will see you again soon in the next video. Bye!